In this topic, we'll learn about the operations on vectors. And we'll start with vector addition. At which position do you think the box will end up in if we apply a 100 Newton force upwards and a 300 Newton force to the right? Yes, the box will move to the right and upwards, like this. The 300 Newton force to the right and the 100 Newton force upwards are both vectors, and the direction at which the box moves as a result of these two forces is known as the resultant vector, or the resultant force. The box started at the position S here and ended at the position E. Hence we have vector SA plus vector AE gives us vector SE. The magnitude of vector SE is equals to the square root of 300 square plus 100 square, and it is equals to 316 newtons, rounded off to 3 significant figures. In order to add up vectors, these two letters must be the same, and this will give us a continuous path. To add vectors AB and BC, we will have the resultant vector AC. Now, how do we add vectors QP with vector QR? You notice that it is not a continuous path. To recall, vectors have magnitude and direction, and the position is not important. Therefore, we can shift this vector upwards in order to form a continuous path now, which is QP plus PR. And the resultant vector will be QR. In summary, in order to add up vectors, do note that the path have to be a continuous path. Otherwise, you can shift the vectors to form a continuous path. This illustration here is not part of a vector concept. It is just to help you to remember vector addition. We have a map of Singapore here with 3 locations: Ang Mo Kio, Boon Lay, and Changi. Vector AB plus vector BC is equals to vector AC. Here, if we go from Ang Mo Kio to Boon Lay, and then Boon Lay to Changi, isn't it the same as going from Ang Mo Kio to Changi? And therefore, vector AB plus vector BC is equals to vector AC. And once again, this illustration is not part of a vector concept. It's just here to help you to remember vector addition better. And that's all for this topic.